Right, well hello today. So we've got a new hat for a new day, and our good old friend Differentiation is going to move on a little bit into the world of tangents and normals. So you may have forgotten what a normal is. A normal is the line that is at right angles to a tangent. So take a moment to note down our first example for today. This is going to be two examples today. Finding the equation of the tangent to the curve y equals x cubed minus 3x squared plus 2x minus 1 at the point 3, 5. So quite a lot going on there. So the first thing I think I'd do if I was sat in an exam is I would put that straight into the graph function of the calculator, press draw, and have a little look at what we're thinking about now. It said at the point 3, 5, so the point 3, 5 is coming in what about there. So we are expecting, if we want the equation of the tangent, it's going to be a straight line, isn't it, with a pretty steep positive gradient. And once we've got that, we can substitute in and find the plus c or minus c, as that looks like that's going to cross way below the x-axis. So let's get started. First thing to do is differentiate that. So we're going to have dy over dx is going to equal 3 times, drop 1 on the power, 2 times 3 is 6, so negative 6x. 2x, we just have the 2 and we lose the constant altogether. So that's our gradient function. Now what we need to know is, what was that gradient when x was equal to 3? So when x equals 3, the gradient is going to equal 3 times, well, 3 squared is 9, take 6 times 3 and then add 2, and if we do all of that, that gives us what, 27, take 18, which is 9 plus 2 gives us 11. So the gradient is 11, and we can then say if the gradient is 11, we're looking at y equals 11x plus c. We've been told the point, so we substitute the point 3, 5, so there's my x value, there's my y value. So we've got 5 equals 3 times 11 is 33 plus c. We were expecting a very negative one on this. We take 33 from both sides, and c must be negative 28. So we are looking at the equation of the tangent being y equals 11x take 28. That is our first solution. Next up we have this little question here, so if you'd like to write that down, and it's saying find the equation of the normal to the curve with equation y equals 8 minus 3 root x at the point where x equals 4. So before panicking on anything else, get the calculator out again, put it into the graphing function, have a look. Now it said at the point where x equals 4. So we're going to have a look at that. Now to think about what's going on with the normal, I'm just going to make a sketch of it first as well, which you may want to pause and do too. Right, here's my sketch. So when x is 4, first of all, if you consider the tangent is going to be doing something like that. So that's the tangent. And then the normal, remember, is at 90 degrees to that, so it's perpendicular to it. So we're looking at the line that's going to go straight across it, the opposite gradient. So that's what we're looking at. And let's having a little look at that from the sketch. I'm expecting something that's going to have a positive, not too wackier gradient. So somewhere around about 1-ish, I guess. Now we've done the sketch and got a bit more of an idea of what's going on, if I write down the equation again, we've got to differentiate, haven't we, if we're going to find what the gradient is at that point on the curve, and therefore find the normal. Now at the moment we've got that in a root, so hopefully we're getting quite good at doing this now, but I need to turn that into a power of x, so that's the square root is to the power a half, and then I'm going to need to differentiate that, so that'll be dy over dx equals, the constant disappears, a half times -3 is -1.5 or -3 over 2, and the power of x will be -1/2. So that is my gradient function. So then the gradient when x is 4, because that's where our point where we want to know, so when x equals 4, the gradient is going to equal -3 over 2 times 4 to the -1/2, which is what you could do it on your calculator, or we could just think about it. We're looking at 1 over the square root of 4, aren't we? And the square root of 4 is 2, so that would be a half. So that would give us the gradient being 3 times 1, 2 times 2, minus 3/4. And we were looking for something that was negative and close to sort of 1-ish. So minus 3/4 sounds about right. Now, so that's the tangent though, isn't it? And that's what we were looking to be negative, and positive would be the normal if we look back at here. So gradient of the normal is going to be the negative reciprocal. So from negative it becomes positive, turn the fraction upside down. So that's the gradient of the normal is 4/3. So then we can say that our equation is going to be y equals 4/3 x plus c. Now we know what our x value is, but what's our y value? So the original equation was y equals 8 minus 3 root x. Well, we know our x value is 4, so y is going to be 8 minus 3 times the square root of 4 will be 3 times 2, so take away 6 from that is going to give us a y value of 2. So substitute the point 4, 2 into here, gives us 2 is going to be equal to 4/3 times 4 plus c. 4/3 4 is going to be 16 over 3. So I'll carry this on the next page. So if we just work this through, you get 2 equals 16 over 3 plus c. So c is going to equal 2. Take 16 over 3, which is, I could work it out, but you know what, I think I'm just going to use my calculator here and just put it in there, and that says minus 10/3. So we've got y equals 4/3 x minus 10 over 3. So this looks like one where it would be nice, we could leave it like that, but it'd probably be nicer to put it in a slightly different form. If we times everything by 3, we get 3y equals 4x minus 10, and then the more normal thing when it's in this way is to say we've got 3y minus 4x plus 10 is equal to 0, but any one of those will be fine. And you're going to want to practice these skills a little bit. So if you're looking in the book, exercise 12F on page 269, if you could do questions 1, 4, 5 and 6 today, that should give you plenty of practice. And let me know if you need any more assistance. Thank you very much. Goodbye.